Section 6.6 Day 1, Fundamental Theorem of Algebra. Essential question, how do I write a polynomial given the real and non-real roots? You are familiar with being given a polynomial and finding the roots. Now, we're going to give you the roots and you're going to find the polynomial. Who uses this? Aerospace engineers may find roots of polynomial equations to determine dimensions of rockets. Here is a table of statements that are equivalent to each other. A real number r is a root of the polynomial equation when you set the polynomial equal to 0. If you take that root and plug it back in for x, you're obviously going to get 0. That's what this p of r equals 0 means. R, in addition to being called a root, is also an x-intercept of the graph of p of x. And I'm going to scroll down here. It's also a 0 of p of x. We can also state that x minus r is a factor of p of x. Recall, when something's a factor, when you divide, you get a remainder of 0. And that's exactly what this line says. So these are statements that we can use interchangeably, and they all mean the same thing. Now, today, we are going to give you real roots and also complex roots. The key to remembering when you get a complex root, typically you're going to be given one complex root, and you need to know that they come in pairs. So if I have one complex root, a plus bi, I know the other one is going to be the a minus bi. And we'll do an example to demonstrate this. So let's do example 1. Write the simplest polynomial with these roots, -1, -1, and 2. First of all, you can see that there are 3 roots. As a result, we know that the degree of the polynomial is going to be a 3. So when we write out our p of x, that's the name of our polynomial, we write the roots as factors. So x minus the first root, x minus the second root, and x minus the third root. Well, that's just going to be x plus 1, and x minus 2. Next thing we are going to do is we're going to FOIL. That's going to be x squared plus 1x plus 1x plus 1. If I combine like terms, I'm going to get x squared plus 2x plus 1. We now have a trinomial times a binomial. So we're going to multiply every term in the trinomial by every term in the binomial. When we do that, we get x squared times x, that's x to the third. X squared times -2 is -2x squared. 2x times x and 2x times -2. Well, that's going to be 2x squared minus 4x. And then 1 times x is x, and 1 times -2 is -2. Combine like terms. Well, x cubed comes first. That's the biggest exponent. There's no other x cubed. The -2x squared, so we're done with that. These two cancel each other. Then we have a -4x plus x. Well, that's a -3x, and then a -2. There's our polynomial. If we wanted to name it, we would call it a cubic trinomial. We can see that the degree of the polynomial is a 3, just like we said it would be, because there are 3 roots. Example 2, we're going to save for class. Example 3. We have a reminder, complex and imaginary roots come in pairs. Okay. Write the simplest polynomial with these roots. Well, we have a 2. That's a real root. We have an imaginary root of I. Well, we can write that. Remember, complex numbers are in the form a plus bi, a minus bi. They're conjugates of each other, complex conjugates. So the I by itself really represents that. So that means we're going to have another root like that. So that's going to be our other root, negative I. And now we're ready to write out our polynomial. Okay. X minus 2, x minus I, and x minus a minus I is x plus I. What's going to happen here is we're going to be multiplying i's together, and we're going to get I squared. And we need to remember that that equals negative 1. So now comes the helpful suggestion here. When we're dealing with imaginary roots, you want to FOIL the imaginary factors together first. And when I do that, I get x squared. The outside is plus xi. The inside is minus xi. And the last is negative I times I is negative I squared. The objective of multiplying these two factors together, what's going to happen, because they're complex conjugates, the two middle terms are going to cancel, and then we're going to end up with that. Well, we know that I squared is a negative 1. So if we plug in a negative 1 in for I squared, let's just show how we do that. Don't want to make anyone confused here. We're going to have x squared plus 1. All right. So now we need to FOIL again. So right here, I'm going to just go like that and write that we FOILed. And now we're going to FOIL again. X times x squared is x to the third. X times 1 is x. Inside is negative 2x squared. And negative 2 times 1 is negative 2. Put it in standard form. We get x cubed minus 2x squared plus x minus 2. And if we wanted to be extra smart, we could name this polynomial. It's a cubic because the degree is 3. Polynomial with 4 terms. Example 4, we're going to do in class. And also, I'm going to write this now so I don't forget. We're not using those. We're going to be using negative 4 and 3i instead. So change that in your notes, please. And here's our video questions. So write the simplest polynomial function with the given roots. These are the real zeros. And write the simplest polynomial function with the given zeros. We have a real and we have a non-real. So recall, if it's a negative 2i, we also need a positive 2i. We only do that with complex roots. So if we set this up, x minus 3, x minus a minus is x plus 2i, and x minus 2i. And what I suggest you do is FOIL these first. And remember that I squared is negative 1.